talked about when taking a survey, a lot of the times whoever's conducting the survey will use a sample. What is a sample? Liam. Right, you take, if it's not practical, what does that mean? Not practical to ask the entire population the question of your survey. What does that mean, not practical? Not needed, maybe not even possible. So they use a sample and they say, I'm going to take this sample, I'm going to get the results from this sample, and that's going to help me draw a conclusion, that's going to help me make a prediction. So let's take a look at the Learn About It right on page 226. A veterinary clinic sent surveys to 500 pet owners asking, would you use our excellent new boarding facility to board your pet? Surveys were returned by 161 pet owners. Based on the sample, can you predict that more than 300 of the 500 pet owners would be using the facility? Okay, so let's take a look at some of these numbers. Total population was 500. Okay, the sample, they had how many that were returned? 161. Okay, so they tried to ask everyone, at least everyone who the question pertained to, but did not get a response from everyone. Therefore, they have to use this smaller number as their sample. That's who returned it. And for every 5 that said yes, 2 said no. Okay, so 5 that said yes, 2 said no. Did more people say yes, or did more people say no? More people said yes, absolutely. So we need to take this information and try to figure out the answer to the question, which was more than 300 of the 500. Would they expect to get more than 300 from this total population based on the results given? Okay, so if it's 5 for every 2, let's go with the number of yeses, which was 5, over the total number of responses of this right here. Am I going to put 5 over 2 to represent the total, or 5 over what? Nah, that's a little high. For every 5 that said yes, 2 that said no. That's a group right there of how many? 7. 5 of the 7 said yes. See how that works? 5 yes, 2 no. Gives you a total of 7. Got that? Okay. That was from the sample. I'm going to use that number, that 5 to 7, and I'm going to try to figure out how many of the total population would that be. Okay. Totals usually go on the bottom, right? So the total ratio for this was 7. Total population was 500. Now, how am I going to figure out this missing number? What strategies can I use? Liam? So first thing I want to look for is, is there a relationship? Can I multiply 7 times anything to get 500? No. Can I simplify an existing ratio? Can I simplify 5 over 7? It's already simplified. So Liam is suggesting we're going to cross multiply, and then we'll divide by 7. What is 5 times 5? Plus the 2 zeros. Okay. We're going to divide by this number that's left over, the 7. Okay. Put a decimal there just in case. Now we do our division. 7 into 25. 7 into 40. 7 into 50. need to finish it. What was the question? Can you predict that more than 300 of the 500 pet owners would use the facility? Can I stop there? Because I can assume right now that it's somewhere around 357 from what I found out. So yes, based on the samples, you could make a prediction from the conclusion that you would have more than 300 people use that particular service. Because if 5 for every 7 said yes, then that works out to be about 357 out of 500. That's how that works out. That's how that calculates out. That's how that projects. Okay. We didn't even have to figure the rest here. Doesn't matter. Whether it's 357 or if it rounds up to 358, is that still over 300? 357 or 358, isn't that still over 300? Yeah, so you answered your question. It's done. Okay. So let's take a look at a couple of examples, more examples like that. It's relatively new information to you, so don't worry right now if you don't catch on right away. Do some more. Okay. Let's go to guided practice, page 227. Use these data for exercises 1 and 2. All right, so let's write down some of this information like we did. Total population is 280 students, okay? 280 students in the school. The school is probably about twice as big as ours. The sample was 50 sixth graders. Now the question, should the students write to their state representative about funding for the municipal zoo? Okay. For every 7 yes responses, they had 3 no responses. All right. Now, question number 1, we got all the information that we need. Question 1, based on the results of the 6th grade survey, can you conclude that more than 100 of the students in the school would write to the state representative? Okay, so what is the total? We're going to find the yeses or the nos. Should the students write to their state representative about funding? 7 said yes, 3 said no. So that's 7 out of how many total? Right. 7 out of 10. And the total population of the school, if the total of 10 goes on the bottom, so does 280. Is there a relationship between 10 and 280? Desi, times what? 28. So what you need to do then is multiply 7 times 28 and answer the question. Go ahead. For number 1, Larissa, Desi. Yes, because what was your answer? 28 times 7. 196. So 196 of the 280 said that they should. Is that more than 100? Yeah, so they're good. Number 2, is the conclusion based on the survey results valid? In other words, if you've got 280 students in your school and you took a random sample of 50 sixth graders, Is that a valid conclusion to make? Frank, why? It's only sixth graders. I mean, not only sixth graders, but if you're going to have a representative sample of your school, any other suggestions as to what maybe would be a better idea to get a better, a more accurate response from 4K through 8th grade? Liam? Yeah, maybe take a few from each class randomly. That might give you a little bit better of an idea. Okay. Any questions on that? We took what the results were, found an answer. Okay. Not so bad. So on page 228. Another problem here. I'm going to have you do numbers 3 and 4 on your own, setting everything up. All the information is there at the top. So you just need to follow the same model that we did for the last couple of problems. Write down the information that's important to you. Use it, then do some calculations to answer the question. Go ahead. Give you a few minutes. You can do this. Okay, what is some important information that we need to know? Total population was what? Okay. Sample? Sample was 80. Okay, very good. And the question, should cats be licensed the same way as dogs? And the results, for every 13 yes, we had 7 no. Okay, now the question says, or the conclusion, most people thought in the town thought cats should be licensed. Now, number 3, based on the results, can you conclude that more than 2,500 people think that cats should be licensed? How should we set this up? So yes would be a ratio of what? 13 to 20. And for 4,000. So 20 to 4,000 is a relationship of times what? Times 200. So 13 times 2 is 26 with 2 zeros, 2,600. So the question is it more than 2,500? Yes, it is. Okay. Jasmine. Sure. Take the numbers and kind of break them up a little bit. So when you look up at 20, what's 20 times 40? How did you get from 20 to 40? Times 2. And how many extra zeros do you need? 2. That's why it's 200. And then from here, if I multiply by 200, what's 13 times 2? 26 with 2 extra zeros gives us 2,600. However you get this is okay. Did you not see a relationship from 20 to 4,000? What did you do? Did you multiply 4,000 times 13? Because you could have. You could have done that and then divided by what? 20. You would still get the same answer if you do everything correctly. See, when you're finding this missing number here, and you've got basically 2 fractions or 2 ratios, however you want to look at them, there's more than one way to do it. Okay? It's kind of like if I said, all right, I'm going to meet you all at Milwaukee Lutheran High School at 5 o'clock tomorrow. Okay? Would we all take the same route to get there? No, not necessarily. We could. We might. But the point is, we need to get there. However you get there, by plane, by train, by bus, by bike, whatever, however route you get there, what's important is that you get there. Same thing here. Some of you will get there faster because maybe you live closer to the high school. Some of you might take you a little bit longer. Some of you might have car trouble on the way there. Might get a flat tire, run out of gas. Might take you a little longer. Might take you a little longer here. It's okay, but get there. Okay. Question 2. Is the conclusion based on the survey result reasonable? Well, the answer is no. What's wrong with it? The answer is no, but what's wrong with it? Why is it no? Why is it no, not yes? Liam. Yeah, good. Way to catch that. There's only 8, and there's 4,000 people, and they only took 80. It's a small amount for a sample that large, for a population that large. Okay. So, yeah, they could have probably done better. Okay. I'm going to give you your assignment. Short lessons today. It's okay. Gives you more time to work on other things. Sometimes they go long, sometimes they're shorter.